Hi, let's talk about tangents and normal, which are topics we've learned in calculus, especially in differentiation. Alright, so let's get started. Let's talk about normal. So suppose that we have a curve with equation y equal fx. And at point A with coordinates x1, y1, we have the line which is called tangent and the normal. So what is tangent exactly? Tangent is a line that is just touch the graph. Okay, just touch the graph at some point. In this case is at point A with coordinates x1, y1. This is a tangent. The full name of this tangent is called tangent to to the curve. The curve y equal f of x at point A, which is x1, y1. Okay? And the gradient of the tangent. Gradient of tangent is found by the differentiate of y with respect to x, or derivative of y with respect to x at point x equal to x1. So we have to plug in x equal to x1 into dy by dx. Okay, into the value x of dy by dx and calculate it so that it turns to be the gradient. And suppose that the gradient of tangent is just a constant. Let's say it is m. Okay? Let's say it is m. Alright? This is a tangent. Okay? So, what happened to the equation of the tangent? So let's come to the equation of tangent. We know that the point that tangent passed through, which is point x1, y1. Okay? Which is this point. X1, y1. And the gradient is m. Okay? So the equation of the gradient turns to be y minus y1 equal to the gradient of the tangent, okay, which is m, times x minus x1. So m is, this is the gradient of the tangent, okay, gradient of the tangent, and this is the equation of of the tangent, okay, at point, at this point, all right, at point x, at point A, okay, at point A. Now, once we have the equation of the tangent, we need to find the equation of the normal. And the normal at point A is perpendicular to the tangent at the same point at point A. So, the full name of this normal here is called the normal to the curve y equal f of x, okay, at point, which point? Point x1, y1, okay? And the gradient. So what happened to the gradient of the normal? So let's review a bit about the gradient of perpendicular lines, right? So suppose that you have this line, which is called L1, and this is line L2, okay? Suppose that line L1 and L2 are perpendicular. So L1 is perpendicular to L2. Okay? So what does it imply? It implies that the gradient, suppose that the gradient of L1 is, let's say, is M subscript L1. And the gradient of L2 is M, okay, subscript L2. So, if you have the line L1 perpendicular to L2, what happened to the gradient? The gradient of L1 times the gradient of L2 equal -1. Okay? Or if you have the gradient of L1 multiplying the gradient of L2 and it turns out to be -1, it can imply that L1 is perpendicular to L2. Okay? Got it? Okay, I hope I recall this topic. You can read this topic in the topic called coordinate geometry. Okay, coordinate geometry. All right, so let's go to the next one. Let's talk about the normal. So we know that normal is perpendicular to the tangent. So what happened to the gradient of the normal? What is the number multiplying m and it turns out to be -1? That number is -1 OM. Okay? That number is -1 OM. Alright, so let's go to the equation of the normal. So the normal passes through the point A with coordinate x1, y1, and the gradient is -1 over m. So you're gonna have this equation. So we're gonna have equation y minus y1 equal to -1 over m times x minus x1. Okay? And this term right here is the gradient of normal. Okay? So I hope you don't forget how to write the equation of the line passing through point x1, y1, and the gradient equal to m. Okay? So what happened to the equation? Equation turns out to be y minus y1 equal to m times x minus x1. Okay? Right? Now, are you ready for the example? Let's do the example. Yeah. So we have the equation. We have to find the equation of the tangent and the normal to the curve y equal to 3x squared minus x plus 8 over x. Okay. So I don't know what does it look like. I don't know what the curve look like with this equation because we have x, we have 8 over x. We know that we cannot substitute x equal to 0 into this equation because we have x in this denominator. Okay, so I don't think it's look like the quadratic curve. Oh, sorry, a quadratic curve. Okay, but in this question we have to find the tangent and the normal to this curve at the point where x equal to 2. Okay, so let's say we have this y-axis, x-axis. I know what it look like, and we know that this graph, we don't have the point on this graph, so that x equal to 0. Okay, so this graph doesn't pass through this axis, this y-axis. But it doesn't matter, right? Because we just need to find the equation of the tangent and the normal. I suppose look like, maybe look like this. Okay, I'm not sure what it look like. It might be like this, right? So now x equal to 2, suppose that it is here. Okay, and let's write down the tangent. The tangent lines look like this, right? So it must touch this graph with this equation at point x equal to 2. And then we have the green line, which is the normal, and the normal must be perpendicular to the tangent at point with where x equal to 2. So this is our tangent. Okay, this is our normal. The green line is called the normal. Okay. So the first thing that I want to do is to find the y coordinate of this point. All right. So when x equal to 2, let's calculate the value of y. So it turns out to be 3 times 2 square minus 2 plus 8 over 2. So it turns out to be 3 times 4 minus 2 plus 4. This is 12, right? 3 times 4 is 12. 12 minus 2 is 10. 10 plus 4 is 14. Okay? So this point is with coordinate 2 and 14. Let's find a tangent. To find a tangent, we have to differentiate this equation with respect to x, right? So we have to find dy by dx. Okay, derivative of y with respect to x. So it turns to be d by dx of 3x squared minus x. Okay, now we have 8 over x. 8 over x is 8 times x raised to the minus 1. So we're gonna have this one and find the differentiation, right? Find this derivative. Okay, so it has to be 6. So 2 times 3 is 6. And the exponent must be subtracted by 1. 6x minus 1 minus 8x raised to the minus 2. Okay, so it turns out to be 6x minus 1 minus 8 over x squared. This is the differentiation. Now we can find the gradient of the tangent at this point. So the gradient, okay, of the tangent at point, this point is 0.214. We have to plug in x equal to 2 into dy by dx. Okay, so it turns out to be, I gotta call it dy by dx and substitute x equal to 2. Alright, substitute x equal to 2 into here. So we gotta have 6 times 2 minus 1 minus 8 over 2 square. So it turns out to be 12 minus 1 minus, okay, 8 over 4 is 2, right? So it turns out to be 9, right? 12 minus 3 is 9. Okay, so this is the gradient of the tangent. All right, now what about the gradient of the normal? We can find it immediately, right? So the gradient of the normal at point, let's say point, this is 0.214. We know that the gradient of the normal is perpendicular to the tangent. So the gradient of the normal multiplying the gradient of tangent must be minus 1. So what is the number right here? Multiplying 9 and it turns out to be minus 1. That number is minus 1 over 9. Okay? So the gradient of the normal must be minus 1 over 9. So now we can find the equation of the tangent and the equation of the normal. Okay, so the equation of the tangent, okay, at point, what is this point? 2, 14, and okay, with gradient, what is the gradient? With gradient of 9, right, is turns out to be y minus 14, okay, y minus 14, and then what next? Equal to the gradient, right? The gradient is 9, so it turns out to be 9 times x minus 2, okay, and then we're gonna have y minus 14 equal to 9x minus 18, and we move minus 14 to this to the right side, so we're gonna have y equal to 9x minus 18 plus 14, so we're gonna have y equal to 9x minus 4. So this is the equation of the tangent, okay. Now what about the equation of the normal? So the equation of the normal line, okay, at which point, at point 2, 14, what is the gradient again? Gradient is minus 1 over 9, okay, so with gradient of minus 1 over 9, so what does it turns to be? It turns to be y minus 14, right, because it's passed through the point 2, 14, equal minus 1 over 9 times x minus 2, right, and we distribute minus 1 over 9, okay, so we're gonna have, so I want to multiply by 9 both sides, okay, let's multiply by 9 both sides, so we're gonna have 9y, and 9 times 14 is minus 126, x minus 2, so we're gonna have, oh, subtract, okay, subtract and plus, right, okay, subtract and plus, and I want to have variable on the same side. I'm going to move minus x to the right side, to the left side, so we're gonna have 9y plus x equal to 126 plus 2, so we're gonna have 9y plus x equal to 128. This is the equation of the normal, okay, the equation of the normal, right, okay, and this is example 1.1, okay, so if you have some time, let's try to do example 1.2, okay, so we have the curve y equal to x squared minus 5x squared, okay, minus 5x squared plus 3x plus 1, right, okay, at point, okay, at point minus at point 4 minus 3, and point B 1 0, okay, the normal at point A and the normal at point B meet the point C, right, meet at point C, but I think we have the typo here because this is x squared and minus 5x squared, so for this one I have to change into x cubed, okay, let's change into x cubed, right, this is x cubed, okay. Now the first question is to find coordinates of C, so I think you can do it right now, right, because if you understand the previous example, you can know you can find the coordinates of C, because if you can find the equation of the normal at point A, and you can find the equation of the normal at point B, you will have two equations, right, two equations of normal, and these two normal meet at point C, So we have to use simultaneous equation to solve the equation of normals, right? And so for x and y and find c. Okay, so you get have equation 1 y minus 4, okay, equal to, let's say, m1, right? Y minus 3, okay, minus 3 equal to m1, and x minus 4, this is the equation 1, right? And another one is y minus this one 0 equal to m2 and x minus 1, this is equation 2. Okay, these are the equation of the normal. Okay, all you have to do is to find the gradient of the normal m1 and m2. Okay, where m1 and m2 are the gradient of the normal. Okay, of the normal, right? At point A and B respectively. Okay, so you can look at example 1.1 in order to do number 1 here. Okay, so I will give you this example as a homework, and next time we will walk through this example. Okay, we will check question 1 and question 2. So that's it for today. Okay, that's it for today, and see you in the next class.